Welcome back. Today we're going to go over some regularization techniques in deep learning. But before we start, hit the like button, subscribe, and share to anyone you know taking the AWS Machine Learning Associate exam. So, regularization encompasses any technique that reduces a model's tendency to overfit training data. Overfitting occurs when a model learns not only true patterns, but also noise, leading to poor performance on unseen data. You'll recognize overfitting when training accuracy remains high, but validation accuracy plateaus or declines, or when the model continues improving on training data while validation metrics worsen. AWS SageMaker supports regularization techniques natively, especially when training deep learning models using TensorFlow, PyTorch, or MXNet. So, data split strategy. Regularization effectiveness depends on your proper data structuring. Split your data into three subsets: training data for adjusting weights and biases, validation data for tuning hyperparameters and detecting overfitting during training, and test data for evaluating final model performance. In SageMaker, upload these splits to S3 and configure input channels: train, validation, test when launching training jobs. The separation ensures you can monitor overfitting in real time and make informed decisions about when to stop training. So, simplifying the model architecture. Before applying advanced techniques, consider whether your model is unnecessarily complex. Reduce the number of layers, the depth, or neurons per layer, the width, to limit the network's capacity to memorize noise. If a simpler model reaches similar validation accuracy while avoiding overfitting, prefer it. SageMaker's hyperparameter tuning can automatically explore different architecture sizes to find the optimal balance. Dropout. Okay, so dropout randomly disables a fraction of neurons during each training epoch. During forward passes, it sets some activations to 0, forcing the network to learn redundant representations rather than relying on any single path. This prevents specific neurons from memorizing training data and encourages distributed learning across the network. Typically, dropout rates range from 0.2 to 0.5. CNNs often use 0.5 dropout in fully connected layers. Experiment with dropout rates in SageMaker Studio Lab or SageMaker notebooks to find the optimal value for your specific problem. All right. So, how do you stop overtraining? So, early stopping monitors validation metrics and halts training when improvements cease. Consider a scenario where validation accuracy peaks at epoch 5, while training accuracy continues climbing. The model begins overfitting after epoch 5, memorizing training data rather than learning generalizable patterns. Early stopping prevents this waste of compute resources. Patience parameters determine how many epochs to wait without improvement before stopping. Setting restore best weights to true ensures you keep the model state from the best epoch rather than the final epoch. For SageMaker script mode, include this logic in your entry point script. Built-in algorithms like XGBoost or Linear Learner support early stopping through hyperparameter configuration, excuse me. So, how would you do this in SageMaker? Well, we'll do a brief one. Won't go too deep, but first, you want to upload your data sets into S3. All right, so that's going to be your primary. And then you want to go over to SageMaker AI. Go to training, select training jobs, create training job. And let's see. Description. Is it? Why do I not see it? Why I didn't. This next section is going to be complex. So a lot of this stuff is going to require going in there, making a SageMaker notebook. And that's why we're not going to do it. That's why I thought I was mistaken. So we're going to pause, cancel this. So you're basically going to create a notebook, create a training job within that notebook. And then within that, you'll be able to create your own training script And from there, you'll be able to create a training job that will be able to do what you need within TensorFlow or PyTorch. So it takes a lot more time to set that up, but I want to make these lessons a little more brief, informative. I'm sorry I can't give you those walkthroughs. So to finish this, so a couple of things. Costs are always going to depend on your notebook instance costs, your Studio Lab for SageMaker. They do have free tiers for Studio Lab, but you're going to have to remember that it will incur costs over time. Charges will also apply to the instances, the S3 storage, and the logs, right? Early stopping and dropout improve generalization and save money by preventing unnecessary training epochs. So a job that might run 20 epochs without early stopping could complete in 8 with proper monitoring. So that could reduce costs significantly, 50% or more. Finally, SageMaker Debugger. So SageMaker Debugger provides additional tools for visualizing overfitting. It captures training metrics in real time, plots training versus validation curves, and identifies when your model begins diverging. This visibility helps you tune regularization parameters more effectively than relying on final metrics alone. So for the exam, when questions ask about preventing overfitting, improving generalization, or reducing training costs while maintaining accuracy, regularization techniques like dropout and early stopping are your answer. Thank you for joining. We hope you have a good afternoon. But before you go, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Have a good day.